Hi, geometry students. Today I'm going to be talking to you about measuring angles and what congruent angles are. Talk to you about angle congruency as well. So remember when we learned about segments, the symbol for the segment has the capital letters for the endpoints and it has a segment symbol above. But remember, there's a different symbol when we want to talk about the measurement of a segment. The measurement of a segment are two capital letters representing the endpoints, but there's no segment mark above it because that's the symbol for the distance between A and B, or that's the symbol for the measurement of this segment. So segment and the measurement of the segment have two different symbols. And the same is going to be true for angles. You learned how to name an angle in the previous video, and in this video we're going to talk about measuring angles, and the symbol for the measurement of an angle has a little m in front of the angle's name. Now, measuring angles is a lot like measuring segments. When we measured segments, we used the ruler postulate, which stated every point in space can be lined up with a real number coordinate. The same is going to be true for angles, only with angles we're going to be using the protractor postulate. And this is a protractor. And when you use a protractor, you put the vertex on a little point that's always in the middle of the bottom bar of the protractor, and you lie one of the rays or one of the sides of the angles up with a number on your protractor. And then you compare the two numbers. So notice that with a protractor, there's the outer ring and the inner ring. And you can choose whichever you want as long as you're consistent. Whenever I see one of the rays lining up with 0, I like to choose that. It'll make life easier for you, and I'll show you as I model the problems. So here I would choose 0, and I would come in the inner track, and up here, the number that is with the other ray is exactly in between 130 and 120, so that's 125. So there's a real number associated with each side of the angle. Now remember, when we measured segments, we found the measurement of a segment as the absolute value of the difference of the coordinates. So we're trying to measure segment AB. It has a coordinate here and a coordinate here, and the measurement is the absolute value of the difference of the coordinates. And it's the same way with measuring angles. You have to find the real number associated with each ray, and you can either do them both on the outer or both on the inner. And then the measurement of that angle will be the absolute value of the difference of those numbers. So you are welcome to pause the video and practice finding the measurements of all 4 of these angles if you feel ready. Otherwise, feel free to watch one example before you do so. If I want to find the angle of measurement NKM, the first thing I would do is use a highlighter to highlight that angle. Angle NKM is the angle that goes through point N with vertex K and then goes out point M. So through N, vertex K, out through M. So highlight the angle and then decide, do you want to be on the inner or outer track? Whenever I see a ray line up with 0, I like to choose it because it makes the math very much easier. You'll get the same answer either way, but I chose the inner track. So this ray lines up with 0, and this side, this ray side of the angle is right in between 30 and 40, so 35. Once I have my 2 real numbers, then I find my measurement, which is the absolute value of the difference of those 2 numbers, or 35 degrees. So now pause and find the remaining 3 measurements of these 3 angles. Jot them on your own paper and then press play for the solution. Angle LKN, LKN. I'm going on the inner track, 0 and 145. So the measurement is the absolute value of the difference. Angle HKM, HKM. This time I saw 0 was on the outer track, so I chose to go on the outer track, 0 for this side and 145 for that side. And the measurement is the absolute value of the difference of those numbers. And angle, the measurement of angle LKM, LKM, I decided to go on the outer track. And so this number's right in between 30 and 40, so 35. And this number's right in between 140 and 150, so 145. And the measurement of the angle is the absolute value of the difference of those numbers. Now we can name angles, types of angles, or we can put angles into categories based on their measurements. Acute angles are angles whose measurements are between 0 and 90 degrees. Right angles are angles whose measurements are exactly 90 degrees, and we're going to be doing a lot of work with right angles later in the course. An obtuse angle is an angle that's bigger than 90, but still less than 180 degrees. And a straight angle is exactly 180 degrees. Now, these are the angles we were just talking about. You could also have a reflex angle, which is greater than 180. We are not going to be studying reflex angles in this course, though you will see them when you get to pre-calc if you decide to take that course. We will be talking about the full rotation, 360 degrees, later in the course. So pause the video and find an angle that matches each of these descriptions. So an acute angle, an example, there are many correct answers, but one correct answer is angle HKL is an acute angle because 0 minus 35 will get you 35 degrees, which is less than 90, so it is acute. A right angle would be exactly 90 degrees. 0, 90, when you'd find the measurement, is exactly 90. An obtuse angle is an angle larger than 90 degrees. If you measure this on the outer track, 0 and 145, that's larger than 90, but still less than 180. And a straight angle would be angle HKN. Now remember that segments with the same measurements were congruent segments. That was our definition. And the same is true for angles. And remember, segments that had the same scratch marks, that indicated that those segments were congruent. And the same is true for angles. With angles, the scratch mark appears like so. When you ever see a scratch mark like this on a diagram, then you know you can assume this. That is what is trying to be communicated, that angle A is congruent to angle B. Now, once you know things are congruent, then you know the definition of congruency kicks in, because congruent angles are angles with the same measurement. That's the definition. So if you see those scratch marks, that means they're congruent. And if you know they're congruent, then you know the definition tells you their measurements are equal. So pause the video and name the congruent angles that are given to you in this diagram. Notice D and A both have one scratch, so we know those are the same scratch marks indicate congruent angles. So angle A is congruent to angle D. Angle E and angle B both have two scratches, so that means they are congruent to each other. And C and F both have three scratches, so that means they are congruent. So one way you can be told that angles are congruent is if they have the same scratch marks. Now let's look at this diagram. Pause the video and on your own paper, write down which angles have to be congruent, which angles are congruent. So if you're given equal measurements, then you can use the definition of congruency to know that if their measurements are equal, then that means the angles are congruent. If their measurements are equal, then that means the angles are congruent. Angles with equal measurements are congruent by definition, and so you can make these statements. KFJ is congruent to NGM, and you can say that angle JFO is congruent to angle LGM. And that is it for today. So I wish you a wonderful day, and I will leave you with these adorable kittens.